in a second. There we go.
Hi, I'm Sam, and I'm here to tell you about the Augmented Reality Monopoly project from the AR Artists. Our project was to create an iOS app that allows you to play a cool version of Monopoly. This is done by superimposing a set of 3D avatars over a set of image targets. The idea is that when you play with your friends, you take your collection of game tiles, you set them each to a unique target ID, and then you go to the app. In the app, you create your profile by entering a username and taking a selfie. You then connect to the game tile by connecting directly with Bluetooth or manually choosing a target. I'm going to select target 1. You then go to settings, and you can connect to players by connecting to the game server, downloading the available games. I'm going to join Monopoly World Cup. I see that Libby has already joined the game. I go back to play mode, and I see both my avatar and her avatar displayed over our chosen image targets. You're now ready to play Augmented Reality Monopoly by replacing the original game targets.
Okay, so we are the AR Artists, and I'm Sam Howes, as you saw in the video. Our project was to create an augmented reality Monopoly app. So what did we create? We created an iOS app that allows the user to play Monopoly in an interesting, cool, fun way. And so as you see, I'm holding the iPad. You see we have 3D avatars that are superimposed over a real-world video feed. And so we created the iOS app to do this. We connect multiple iOS apps via a networked game server, and we use custom hardware that we designed to display the image target on an LCD screen. So this allows the image processing to detect the game tile's presence in the video feed and then display the corresponding avatar. So what's the result? As you saw, we finished it. We were able to implement the system, and we provided a good framework for a future team to expand on. The ultimate goal of this project is to replace the static game tiles with autonomous robots that drive themselves around the board. And so why does it matter? So this project connects people in different locations through a fun and cool game. As our customer, Professor Kia, always said, it allows grandparents to play Monopoly with their grandchildren in multiple locations without having to actually be in the same place. And so this also creates a cyber-physical system that creates a bridge between hardware and software. And you're allowed to, the user is allowed to enter things into the app and see a result in the real world. And so this bridges the gap between real and imaginary, which is true to augmented reality. And so this also serves as a gateway for the public for more advanced products such as Google Glass. So how did we do it? The game server is serving up a REST API that is powered by Node.js with the Express package, and we're using the MongoDB database on it. The iOS app features standard design practices with Objective-C and Cocoa Touch, and it also integrates the image processing part of it, which was developed with the Vuforia SDK and the Unity 3D game engine. So that's a managed code environment that the iOS app hosts. And then on the bottom we have the game tile, which has a ARM K20 processor to run the LCD screen that provide the image target. And we also have the BLE112 smart Bluetooth module to enable Bluetooth connection for a future project. And it's all powered by a 3-volt coin cell battery. So my role in this project was developing the iOS app. And so this has, as I said before, there's two main components. It has the native iOS app that's developed with standard design practices of iOS. And this has networking to connect as a REST client with the game server, and as well as Bluetooth, implementing the Bluetooth Low Energy Protocol with Core Bluetooth. And also a significant portion was integrating this project with Unity. So Unity is a managed code environment. It's written in C#, and this compiles into an iOS project. And I then interface directly with that code and manipulate that the way I want it in iOS to get it display with my interface over top of it, like you saw. And so I also contributed to developing the Node.js web server that Naveen and Koki will tell you more about.
So as Sam just mentioned, we needed a game server, and what happens in this is the iOS devices, they act as the client to the server. So that would be the front end in an Objective-C, C#, etc. And then we have the back end, which is the server, and then that communicates with the MongoDB database. And so what we do is we use the Node.js software platform, which offers a variety of packages, namely Express, MongoJS, and Mongoose. And then that in turn communicates with the MongoDB database. We're hosting this all currently on our Mac Pro. You can see that demo time. And we also have a bit of error checking in the code. So if someone enters like a super long username and potentially bog the database with such a great amount of data, it's going to automatically throw it out. And it does the same for game session names, where players join in to play with each other. And Koki will explain more about the server.
I'm Koki. I worked on the server and the avatar. For the server, we've created a server-end code in JavaScript which interacts with the iOS app. The iOS app will send out an HTTP request, which, depending on what the user wants or needs to do, such as creating a profile or querying for available game sessions, the code will access the database and either store or retrieve the appropriate information and return it back to the app. Other than the server, I also worked on the avatar. The avatars are basically a 3D cube with the user's image displayed on each side of the cube, as shown in the figure. So when you first run the app, the default avatar will be shown with the Monopoly logo image, and only when the user creates a new profile and selects their own user profile image, the script we've created in JavaScript will automatically replace that default image with the new image.
Hi, I'm Olivia Stork, and I was the firmware lead for our project, meaning I was in charge of programming all of our hardware to obtain our desired functionality. I worked mostly with the Kinetis K20 microcontroller, which is sort of the brain of our game tile, if you will. We chose this because because it can run multiple communication interfaces simultaneously, and it also has a top-of-the-line industry-standard ARM microprocessor architecture, the ARM Cortex-M4. The K20's main job is to control the smart memory LCD, which is the face of our game tile, as you can see. We chose this LCD since it's very small and has a high resolution. It has over 9,000 pixels on a screen that is less than 1 inch on each side. The K20 stores the image data that we wish to display, and it sends this data to the LCD with the SBI communication protocol. Our game tile also has a BLE 112 Bluetooth module that is currently not implemented, but there is a solid framework in place should a future team wish to expand upon this. A future team could use this Bluetooth connection to, say, read an identification number off the game tile or send commands to move a robot. All of these custom hardware elements were put together on a PCB designed by Jeannie that she will talk about right now.
Hi, I'm Jeannie, and I'm the hardware lead for the A artist. And so my responsibility is to deliver the actual game tiles, which is a physical piece of hardware. It's 2 by 2 inches, as you can see on the right. And its main purpose is to store and display our target images, as you can see in the top right image. And so basically, it's a circuit board that connects the major hardware components. I was in charge, or am the primary person who have researched and chosen our components. And so I'm also assembling them into our PCB, and they are all powered by 3-volt coin cell battery with 2 buttons. And so as you can see on the right, we have 1 button to toggle between images. One of the requirements of the game tile is to have the images be reconfigurable. So we have a toggle button to switch between multiple images, and we have a reset button to set it back to the first image. And as you can see on the bottom picture, we also have the Bluetooth installed. That is currently not working, but it is a feature for future expansion. And with special thanks to Professor Pisano and Kia for helping us with the process, we open the floor to questions.
Cool project. I had a question about how you picked your parts. You mentioned that you picked the processor because of the state-of-the-art processor and the display because it has a high resolution. I was wondering kind of what requirements of the project motivated those requirements or that choice?
The main driving force behind that was that we implement a commonly used processor that's used in industry a lot. and to develop good design practices. As for the LCD,
We wanted it to be small enough to fit on one square of a Monopoly tile, so that's why it motivated our choice for such a small LCD. There are certain similar ones that are bigger, but this is the smallest we can find.
and also the high resolution allows us to display the specific binary pattern around the outside edges as well as draw names on it.
So why is this better than playing a game of Monopoly online on your iPad? Why use the physical pieces at all?
Because the future iteration of the project is their autonomous robots, which are really cool in general. You can have it's augmented reality, which is it's not being absorbed in your phone and your iPad. It's allowing it to just augment the actual physical world, and so that enhances the real world, but while not trapping you in your iOS app.
Also, it just doesn't stop there. You can use it for other, like Candyland, you're just moving pieces around the board. You're not actually doing anything else.
I was about to ask, I could use this to play any game.
Exactly.
But couldn't I? Like, I could put anything on top.
Exactly. So these are the frame markers and the game tiles are really portable. They serve as an image, a generic image target that the iOS app will draw the avatar over wherever it sees the image target.
Great, thank you.
Thank you very much.